in the year, like I think it's 2009, we created as a human species more data than in our collective history, cumulative collective history up to that point. So if you say 50,000 years till behavioral modernity, you know, not like the 200,000 years for Homo sapiens, but say 50,000 years to behavioral modernity to now, cumulatively in that 1 year, we created more data than we did in our entire human history. And each year subsequent to that, we've created more and more data. So how do you use this data to sort of come to conclusions? When we found the proof of the Higgs boson, or evidence for the Higgs boson, to put it a little better, less legal terms, right? You had to analyze these mass amounts of data. So this idea of big data has led to the idea of computational approaches, especially in the context of machine learning, where we have programs or machines which are able to learn conclusions that they should come up with rather than being pre-programmed by us about it. So the last 3 chapters of the book sort of deal with this idea, and I end the book with sort of an exploration of machine learning and also applying it to data science, talking about data science, whether that's an actual science or not. This ties into research that I do, like fact-checking misinformation and virtual communities and multimedia analyses and digital humanities. And also I do like physics-based models of computer vision. And so the next book that we're doing is about fact-checking misinformation. It applies a lot of these ideas. And so the book sort of takes this thing of going from what's the essence of science? Prediction, great. One of the ways that we can sort of think about majority of the math in there is in information theory and entropy, build up the basics of programming, and then end with sort of tying entropy back to these ideas of machine learning and big data and data science. So that's the book in a nutshell. Now you don't need to go read it.